Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Heinz Grottenegg, a sales manager with Axmann Geoinformation. In addition to his sales duties, Heinz leverages his background in project development and support to conduct FME training courses throughout Europe.
I might welcome you. Thanks for having me here, and thanks for attending this little speech I'm giving. Heinz, my name. We're talking about metadata. It's a hot topic. A lot of people talk to me, what approach I got there. They're working on metadata, or as we call it, mostly a pain in the ass, because metadata is really a disgusting topic. And I just want to show you what we did on metadata in Austria with the Austrian Federal Railways in a project. And also this question mark is towards you. So if you've done anything with metadata, please let me know. We'll be happy to discuss it with you, because this was our first project concerning metadata. And hopefully we can find a way to make it better. Okay, what are you guys going to hear is a short introduction to the project and the motivation, so the problems they had there in Austria, having lots and lots of data but no metadata. So basically the question was, how old is this picture? When was this taken? Is there an update? So it was useless data without metadata, especially in an SDI. Then I'm going to talk about the architecture of this model, then shortly discuss the workflow we have, give an outlook, and then we have time for some questions, of course. Okay, this was a research project in cooperation with the Austrian Federal Railways. All over Europe they have auto photos or aerial photos, AutoCAD files, and a lot of shape files. Then IQsoft was involved as an IT company developing this metadata client I'm talking about today. And the Technical University of Vienna is responsible for the grid shift files. But also the projections were in FME, but they were not accurate enough for the Austrian Federal Railways. And so we had to define, or we are defining at the moment, honestly, grid shift files, which we hope to include in FME 2010, 2011, hopefully 2012. We will see. And the aim of this project was to develop a feasibility study focusing on flexible geodata integration. So of course we did it for AutoCAD files now and some MRSID files, but it should be extensible. That's why we used FME Server, of course. And on basis of an existing spatial data infrastructure. So of course we cannot define our own system and say, hey guys, it works right in Oracle one-to-one. They had an existing Oracle there, and so we had to adopt the schema as well. Okay. Well, the problem was Austrian Federal Railways on-demand emergency maps for them were inconsistent because of missing metadata. So how old is this aerial photograph? When was this taken? Where is the location? What is the bounding box? And so on. Then they had different projection parameters coming out of ESRI, MapInfo, other products. And still, although it's defined to be WGS 84, it's still different. And of course, we had geodata errors, because they had no validation tools, so they were basically bringing, or subcontractors bringing in data, but nobody really checked if they are applying to the schema, if they're correct. So that was resulting, of course, in cost-intensive data capture, and increased the management time at the Austrian Federal Railways. And we had now to search for transparent and quality-assured data integration process, which was done by FME Server. Okay, the goal was now to integrate various data sources into this existing SDI. So we're focusing on structured geodata, also building up an archive, because getting new geodata, we now force the users to enter metadata along with the geodata. Otherwise, it's getting rejected. Then we want to make sure the quality is right. We want to process the metadata, which is not done in FME. It's done by our own client. And then we want to store that in different coordinate systems for these emergency maps. And of course, later on, so that was the aim of the project right here, and for the outlook, we want to export it then from there and make it some kind of geodata shop for the Federal Railways. Okay, I hope you can read it there. That is the architecture of this project. We have data sources, geodata, metadata attributes here for vector, raster as well. WMS should be included then later on. So we're differentiating between static data and dynamic data. And this yellow part, highlighted of course, is done by the FME server. So first, when you get all this data stored, this is an archive client I'm talking about later on. Then we get the quality assurance. Then we convert it. Then we do transformations, also with our own grid shifts, hopefully. And then load it into the SDI. And next to it, this metadata processing of this data is also done by our client, so that it's not in the ETL process, and we try to work to bring that also to the FME server, of course, by experience. So it hasn't been there last year when we started, or has it? Sorry, don't even know. But we want to bring this also up here, but up to now only these yellow parts are done by FME server. Then we store it, the vector data, the raster data, and the metadata in the SDI. That's basically the structure. And there again, we have this original data I'm not talking about. Then I'm shortly talking about this archive. And then moving on to our SDI client with the FME server, storing that to Oracle. That will be the next points for this presentation. So up here we have the archive and the metadata. We were evaluating existing standards. Of course, there are standards out there, but honestly, nobody uses them. So we tried to adopt metadata from ISO 19115 from a user's perspective. So we are also not included in one-to-one. I know it should be one-to-one, but there are many attributes in there we are really not interested in. We copy now this existing metadata for archived geodata into first a database, and then this client starts up the FME server and brings that in the SDI. So we have a graphical user interface in the archive client I'm going to show you for newly captured geodata. So we force people to enter it really before they can send in their geodata. And so we try to establish a well-defined base of metadata imports for all the following components. So what is done, they deliver geodata at the metadata, then it's stored in an archive, and so we have a well-defined structure in there. And from there we go with FME server into the SDI. Okay? So this archive consists mainly of three components. One is a data management system. Therefore, we used an open source software, Fresco. We have something called the Metadata Manager. It's simply a relational geodatabase and an archive client, which was a C# application. So as I said, as soon as they enter the geodata, this pops up and tells him he has to enter metadata as well. The archive client stores that then in two separate databases. One just for the metadata and one for the management system. That's the point that if something gets updated on a geodata site, you don't have to update the metadata. And in between, they are linked with a unique ID, of course. Okay, so that is the first component. So we get it in our database, and from there we have to move on with FME server into the company's SDI. This SDI client we developed was providing a graphic user interface also for map creation, should be then. So what's the deal? The user comes in there or someone of the Federal Railways and says, I'm searching emergency map for that part. So he's searching is the data, and he can search the metadata because metadata is now attached. Is this the newest picture? Is this the newest data? And then he says, okay, out of this, I want to create a standardized map or product. And that's what calls the FME server to get into this archive, translate it into this SDI database, so you get some kind of a standardized product where he knows all the metadata. And this SDI client also takes control of metadata information and storage. So it's simply just calling the FME server. The metadata is not processed in there, fortunately, up to now. And the FME, it's also logging all actions for users as well for the SDI information manager to tell him if there was an error, it was successful, this export. Okay. Now we come to the interesting part, of course, for you. When the metadata is in there and the geodata arrived and he says, I want to create this map, this product there, then it extracts the data from the archive. Then the processing is controlled by the data type. So we have, if it's orthophoto, it calls this workspace, of course. If it's AutoCAD, it calls this workspace. So that's how easy you control which FME server service you want to use. The communication, the FME server reports to the SDI client. This is, I will show you then afterwards if you have time. It's a simple text file telling him what he did. And then it's loading this transformation into Oracle 11 for the Federal Railways or in a PDF or shapefile for these emergency maps. And we are focusing now on this load transform because, of course, this part is done by FME server, where we have 4 steps basically we do by using FME. Quality assurance, then we do the conversion, then we do transformation of the coordinate systems, and, of course, we use the multi-writing capability to produce whether error reports or load it in there and produce a text file or create a text file for the SDI client that he knows everything went fine there. Okay. So the first step here would be quality assurance. So while processing, FME offers a lot of capabilities for quality assurance. We saw Mark Stokes had a presentation on this. And we did a lot of quality assurance in the last 4 years with FME, or mostly. Our project was about quality assurance. So you can check data set organization. You can check the classification of layers, the geometry types, the attributes, visualization, context, and many, many other factors you want to check. So basically it starts easy at the dataset name. You can go over, is there a dataset? That's mostly a good question in the beginning. Then the version, the topology, of course, with FME, self-intersection, zero-length lines, all this stuff can happen. Visualization, attribute existence, and so on. Point on area overlays, every area got a number in there, and so on. And with FME, you can always do this quality assurance. This is done when, because first we just get the metadata and the geodata, and then we have to check, okay, the metadata is now there. Is also the geodata correct? So we do this checking on FME Server. Then it's approved. Then we start a conversion. This cat.js data is going to Oracle 11. The rest, of course, is going to 11G GeoRaster Oracle database. Then we do coordinate transformations, whereby we try now to define grid shifts for Austria with the Technical University of Vienna, and we hope to include them then in FME. And the data sets are stored in the original coordinate system and towards Inspire and all. We'll hear, most surely heard about that afterwards from Mark. ETRS 89 is there used, so we also towards Inspire try to use these coordinate systems. And in the end, we store the data sets in all 3 coordinate systems and create a TXT report, a symbol for the SDI client. Okay, that's what it looks like. This is the archive client. So when a user starts off, also bug in there in German, I see. It simply chooses what data you want to load into what in the DMS, chooses a name, user, password, and so on, and then he says he want to enter now this data into this archive. Then this one forces him here to enter all this ISO 19115 metadata. So you got to enter it. You also got a tooltip there to tell him what to fill in there, because most probably you guys would have done month, day, year. No, not working for us. Do it the European way there. And there you can choose, you can upload laser scan data, AutoCAD. Then he says this group belongs to this standard, because if we take other standards, of course, it's open here. We can also have another standard for Inspire, for example. And then he has to enter all the metadata, store it. If it doesn't work, this also checks is the metadata there. If he does something wrong, he gets the user interface again. And so really force him to enter the metadata along with the geodata. That was the first step we took there. Okay. Then it moves on to the FME server. Now I have an example here. I cannot use the server. Internet is way too slow for that. But I can show it then if you have time on the desktop. For example, if you take such a file, the metadata is in there. It gets a request now. Such an emergency map should be created. Then this DWG file in this case is checked. If there is an error, then it's coming back. He gets an Excel telling him there are your mistakes. Please make sure you get rid of them. And he also gets the original file, just points, telling him this error. In the Excel file, you can see there's an error, and then he can open up this DWG, overlay it with his data, and say, error 1, is this wrong? It's in a map right here. So you can easily detect his errors and get rid of them. If that is not happening, then we do the transformation, reprojection, and we always create an Oracle entry for the Federal Railways, and then he can choose a PDF or a shapefile which he wants to have the map in. The map is coming out as a PDF or shape, and it also creates a report for this SDI client. I've moved so many features to PDF in that and that coordinate system, and the SDI client picks up that text file and then ends up the process. So that's basically a workflow through our application. Okay, how are we doing? Enough time?
10 minutes.
10 minutes. Okay. Then we might have a short look in there. I'm pretty nervous. Mark Arland is here. Hopefully I did best practice. I used one bookmark at least. Fair enough. Okay. Okay. What's going on here? We get the data set. That's for an AutoCAD data set, for example. So what is done, he had brought an AutoCAD again to the archive, given the metadata, and he wants to map now. So this SDI client is calling the FME server. He's taking care of the metadata, but he says the geodata must go with the FME server now. It comes in here, just basically for you as FME users, pretty easy. Does some parameters, variables, goes down here, and the core part is this boy here. That is our online checking service. We took it from our online checking service. We have an abc-geodata.com, a checking service already in the internet for application validation. We took this and put it in a custom transformer because it was done by mapping files years ago. Inside this custom transformer, you can see it's checked, and we have an error. Then it's creating error DWG file, AutoCAD, and the report, which is an Excel. If it's okay, then he moves on and creates here the shapefiles, PDF or Oracle entry. That's basically it. If something goes wrong up here, so look, completely wrong, he misses something. Of course, I'm Austrian, so I gotta have a Terminator in there, you know. It's just, Arnold gotta be in there somehow. And after his terminators, if everything goes right, he checks the data. I got a data set here. This one is correct. I take one, this one is not correct, so it has errors in there. And what basically happens also here on the desktop, I'm checking that and want to try to convert it to PDF. There's done a lot of data validation there, so it takes some time to run through. So it's basically coming in there, going up there, getting his variables, and then going in this custom transformer, which has a lot of other custom transformers in there, of course, doing the data validation. If it fails, you should get back here, up here, Excel file. See? Up here it goes to the error, and also an Excel file should be somewhere here. And that is delivered. Now it's just in desktop, but normally outside it's delivered to the user, so he basically gets, there we go, an Excel file, just telling me what errors happen on what layer and what's wrong there. Jesus. That's an original plan I got from them. So you see that FME can help you really to save this 1,040 errors in that one drawing. And next to it, you also get this error DWG, which you can overlay them with the AutoCAD to see where the errors happen. Now, better case, he got rid of all his errors, so we take a plan which is error-free. There we go. Say OK. So this one should have no errors in there. It's a little bit smaller. It's a little bit faster. So I choose PDF, so it basically makes a translation here in desktop to PDF in all coordinate systems. If I open them, it's just a geospatial 2D PDF. So I check it, should have some attributes on there. Can just show you that on desktop, but that's what's basically happening for you as FME users pretty easy on the server. And the SDI client takes, next to it, there is also now this text file. Also pretty easy to see how we did that. It's just an approach. To see that he imported 542 objects into this and this coordinate system. And this simple information is taken by the SDI client, and he informs then, okay, it happened, there's your data, there you go. Okay? So that's what we build up on our metadata section so far. Okay, what we want to do in the future, this is working now and running. When he gets that, we want to also add on the other side a geodata shop connection. So what it does, the SDI client calls this archive, transforms it into the database for the Federal Railways, or in PDFs for these emergency maps. But then we also want to have people from the outside, as they have so many data there. They also want to make some money out of it, honestly. Make a geodata shop that you get these products. Therefore, we have to enter a search, which is not that hard because we now got metadata all over the place. Forced to enter that one. And we also want to add a graphical search, so basically like, what was the old product called? I'm too young for that. Before the FME server, spatial array, right? Exactly. Then an e-commerce was probably to get some money out of there. And we want to include grid shift files. So if anyone has done that before, please, would be happy to hear about that one. And also, when I'm here, I want to send Sandra a little letter. Dear Sandra, what we want from you, FME, and Safe Software, is a tight integration of metadata into the spatial ETL process. So that we can do, of course, automated, because I don't want to do much work here with XQuery. So that basically maybe you can take an ISO XML metadata file, some kind of like a parameter when reading and when writing, and then when you do area building, it automatically updates that XML file. Now we have areas in that projection out there, and there it goes automatically. Mark, please. Okay. Reprojecting height is also a topic. It's not in there in FME, so reprojecting height would be great stuff to have in there. Improving security, forget about that one. It's in there already on the FME server. And please, a redesign and a better documentation of the schema mapper. It's a little bit hard to use that one in the beginning. Okay, that's it so far. If you have any questions, please feel free to ask. Thank you.